Hello, everyone, on my side. I will just provide for you a quick overview of the JARVIS project. And we're going to have actually later on a deep dive when it comes to one of the solutions of JARVIS, which is the Airport Digital Assistant. So for now, we're just going to have an overview of the whole project. So, okay. I see the layout, similar issue. So some of the information, I don't think they're readable, but I will just explain. So yeah, we have, the project started it's a 3-year project under Cesar. And we're kind of like in the final phase now, in our last year. So we have 16 partners, and Collins is the project coordinator. We have a strong consortium, and we're also working together with EASA. We have a service agreement with them. So it's been a great opportunity to collaborate on the standards and regulations, like get recommendations from them. And we're gonna go and see. This is our project concept image. So in JARVIS, we are designing, developing, and validating 3 AI-based solutions. We have developed 3 digital assistants that support the flight crew, ATC, and airport operators, respectively, on their everyday tasks. So we have an airborne digital assistant, an ATC digital assistant, and an airport digital assistant. And for each solution, we have developed different types of functionalities. We have explored, as you will see, different types of AI, from machine learning to more traditional, as we call it, AI, more deterministic AI knowledge, rule-based systems. So we're just going to see quickly solution by solution. So starting with the airborne digital assistant, we have been developing 3 features mainly for this assistant. So the ATC instruction and clearance management, which supports the pilot with the ATC communications. The main AI element for this feature is speech recognition. So we're basically digitalizing the messages. It focuses on voice communications. So we are analyzing the semantics of the messages, we are comparing instruction and readback, and we're able to present a verified message to the pilots. And then we have our flight strategy advisement. For this feature, we are taking different types of parameters, both internal and external to the aircraft, like aircraft status, for example, for the internal part, and then external, like weather. And we have encoded different flight procedures, like we have studied many flight manuals to basically try to automate pilot decision making. If something unexpected happens, we have a calculation of a risk on the current flight strategy, and also proposing recommendations on more optimal alternatives to follow. And our last feature is the arrival and runway predictions, which is very similar to the previous feature, so it takes into account different types of parameters. This focuses more on the final phase of flight, so we're predicting the arrival runway and runway pairing. And the other difference is that this feature is primarily based on machine learning, so it has been trained on historical data, wherein the other one is the more deterministic AI, so it's a more of a rule-based type of system. So we have performed some validation activities. All solutions have been validating their concepts. So we had 2 main validation exercises, one at Leonardo and the other one at DLR last year. So each exercise lasted around 1 month, and we had real pilots testing the system. Our primary KPI was human performance, so we wanted to understand what is the impact in cognitive load, workload, situational awareness, and also while trying to maintain safety. So we had two different platforms that we worked with. So one was the regional aircraft simulator for Leonardo, ATR 72 type, and then the A320 simulator for DLR. So we had the chance to explore two different platforms, like understand how the system generalizes as well. And we collaborated with EASA on AI assurance and human AI teaming. As you will see later on, these were basically two of our three main AI pillars. We have a transversal work package as well in JARVIS called Foundational AI, where all solutions are collaborating together, and the AI challenges is basically the main element that brings us together. And we're all trying to build basically human-centered solutions, try to maintain assurance and reliability. For specifically here, for when it came to the flight strategy advisement, which was mainly automated reasoning, as we were working with EASA, we understood that there are not many objectives right now defined. So we worked with them and hopefully having a positive influence as well, for the next AI concept papers, for example, to try to include and incorporate some of the lessons learned and some objectives that we drafted together with them when it comes to that type of technology. So moving to the ATC digital assistant. So similarly, the ATC DA has 4 features that they have been designed, developed, and validated throughout the project. So we have the conflict resolution advisor. So this solution has built on top of a pre-existing tool, a conflict resolution advisor, but here introduced some more AI techniques like reinforcement learning to try to identify, determine the type of maneuver as well as the extent of the maneuver, and also eventually select the aircraft that needs to be cleared for that relates to the conflict. When it comes to the more tactical phase, so in the range of the 10 minutes. And there were 2 validation exercises as well as part of that feature that are completed now. Then we have the short-term forecaster. So this functional module basically has been trained on historical data, scheduled flight plans, as well as combined with live flight information to basically predict the demand up to 8 hours ahead. And the tactical opportunities recommender, which basically computes more efficient alternative trajectories, more efficient alternatives that relate, for example, to flight level change, and then evaluates any potential conflict to basically provide a tactical suggestion to the controller. Again, similar to the first solution, we have been working with EASA as well when it came to the assurance, and the focus in particular for this solution with EASA was the reinforcement learning, because again, there were some gaps, and on their side, it was one of the use cases that they wanted to focus on, as it was a gap in the current concept papers and AI papers. Last but not least, we have the airport digital assistant. So again, I will keep it short here because we're going to see a lot of details in the upcoming presentations. So here, and also there were some things that were mentioned as well from Nikos yesterday. So the idea here is to have the main technology for some of the use cases was computer vision for the detection of the FODs, wildlife, and incursions. And this was on the level of providing an alert, which can be safety critical related, as we don't want to have more excessive false alarms than we want to not distract or introduce any risks in the airport operations. And then we have the predictive models for predicting the turnaround and the passenger flow predictions, and this obviously creates a benefit for the operational efficiency, as we heard as well yesterday, since if we identify deviations on nominal turnaround times before the start of the aircraft, we can take more optimal decisions, and it's the same thing for the passenger flow. That's this one. So some more information on that relates a bit more to, as I mentioned, our transversal work package and how we approach the collaboration with EASA. So in JARVIS, we're trying to create assured, explainable, collaborative, and ethical solutions. And working together with aviation authorities, we're trying to have a clear certification path to be able to deploy. So it's very important from the early stages of the design to take into account different aspects like that, especially for AI, that things are not fully regulated, and there are many emerging standards, like regulatory activities, but nothing like fully concrete. The projects that are involved with AI are big influence, and it's very important to collaborate with the regulatory bodies like EASA to be able to create a solid framework and path moving forward. And we have been primarily, for our collaboration, we have been primarily looking at the AI roadmap and also the concept paper, in particular for identifying the relevant objectives for each solution and each feature, as well as identifying the gaps for them. So I have here some projects learned, collected, which are a bit more relating to the AI. I don't know if they're actually readable. This was supposed to be white, so apologies for that. Okay. So overall, as we have completed our validation exercises and we are consolidating our results, it seems that the digital assistant concepts are promising. We have been receiving overall positive feedback from all the different main actors and end users. Especially when it comes to the workload and cognitive loads. It seems that when the features are working as expected, obviously, they can have a positive impact with planning ahead of time, and also when it comes to the management, for example, in the communication side. And the operational explainability is a big challenge, it seems, because it's finding the right compromise of being able to present enough information to have transparency and build trust, but also not overload the operator and keep a balance and present, for example, information that are relevant to them and not necessarily what the AI developer will want to see. If something is not working, we want to make it like having a meaning for the operator. And it was actually something that was, I think, pointed out also in the sessions that we had yesterday. So it was very interesting to see some of the things we discussed that were already part of the presentation. So hopefully it's going to the right direction. So there is a big importance on the data gathering and the effort that it takes to collect the data, analyze the data, process the data, Specifically, when it comes to the airport solution, for example, as we saw as well presented yesterday by Nikos in the architecture, I believe, like you could see all the different like data providers that they had to coordinate together to make this happen, which can be very challenging, and also speaking the same language, agree on the data formats and all of that can be very tricky. Not to mention, obviously, then the training of the AI algorithms, which also like has many challenges when it comes to the data. Some human AI related challenges, also very similar points that were presented, that were concluded yesterday from the roundtable discussions. How do you measure effectively the human-machine interactions, having the right tests in place, like usability tests and all that, as well as then the eventual long-term impact when it comes to the de-skilling and over-reliance on AI. How do we keep the situational awareness there on the appropriate level while we create more and more accurate solutions and operators trust more the tools? And what happens if something unexpected happens? How can they take control back? And making sure that the human counterpart is in charge and has control. This is something that it was a very important point for all the JARVIS solutions. We don't want to override the human. We want to support them. We want to enhance them and not replace them. So this was kind of like our driver there. Just make their life a little bit easier. And also training for learning how to work with AI. Again, going back, I always go back to the roundtable discussions, but they were very, very insightful and very aligned, apparently, with the JARVIS lessons learned. So it seems that the new roles of the operators are going to be very different as we move forward, and more AI is introduced, more automation is introduced. Maybe like your typical like ATC operator or pilot, like will have to have some more awareness and understand a bit more like, system expectations and like limitations, like when it comes, for example, to AI. And it's a collaborative effort, like everybody needs to come together, subject matter experts like developers, and like have a mutual kind of learning. And last point, working with the end users from the beginning of the project, as well as subject matter experts, seems to be crucial. We had many iterative processes, like we started with some, basic requirements, like a basic design, low-level prototype, and then we were going back to the end users. For example, for the airborne case, we had many pilot workshops, so we were getting feedback when it comes to the functionalities, the human-machine interface as well, and we were always making improvements. So it's very important to incorporate everybody's views and feedback in the design and respect the end user. And it's also something that is very challenging because, for example, when it comes to the pilots, there are different schools, if you want. So depending on what are you used to, like you're gonna give like maybe a bit more of a bias feedback. So for a developer, a designer that wants to kind of build a more general solution, try to keep the balance is very difficult. So we had to customize on a level, but still like try to also find what is overall, like what are the common challenges, what are they struggling the most in general. So yeah, and I believe that's it. We also have some the QR code to our LinkedIn page, and also some links for our project page, so you can have a look after to just see more of our activities. Thank you.